In this video, we will explore the key aspects of heat treatment, providing you with the essential knowledge to master the process. Be sure to take notes if needed and check the description below for a self-assessment form to test your understanding. Don't forget to subscribe to the channel for more informative videos, and feel free to leave a comment with any questions or feedback you may have. Let's deep dive into heat treatment. Safety first. Follow instructions carefully. Handle equipment with care. Stay alert to fire hazards. Be aware of chemical properties and risks. Focus on the subject matter. Take precise measurements. Research the topic thoroughly. Record and analyze data systematically. Draw clear and logical conclusions. Safety policy. Ensure employees' safety and health as a top priority. Aim for zero accidents and injuries. Responsibilities. Everyone in the company shares responsibility for safety. Readiness. Do not work under the influence of drugs or alcohol. Equipment. Use. Operate equipment only if trained and authorized. Follow all instructions and ensure safety guards are in place. Gas cylinder safety tips. Treat all cylinders as potential hazards. Secure cylinders with chains or straps to prevent falls or impacts. Always keep caps on when cylinders are not in use. Store cylinders away from flammable substances like oil, gasoline, or solvents. Avoid using cell phones near cylinders. Basic furnace safety instructions. Owners-operators must ensure safe conditions are maintained at all times after installation. All the furnaces must be installed and used according to technical regulations, standards, and specifications. Maintenance is done regularly on company equipment as per the schedule. The schedule shows how often maintenance is needed. Tasks are handled by the plant superintendent, maintenance technician, or heat treater. Maintenance follows a checklist, and all tasks are recorded. Any repairs or adjustments are logged in a maintenance book. What is heat treatment? Why is heat treatment necessary? How is heat treatment performed? What is heat treatment? Heat treatment refers to a process or series of processes involving the controlled heating and cooling of a material in its solid state to achieve specific desirable properties. Why heat treatment is important? Heat treatment enhances the mechanical properties of metals, making them stronger, tougher, and more resistant to wear. It also improves ductility, hardness, and machinability depending on the needs of the material. Before heat treating a tool, significant investments have already been made in materials, machining, and overhead costs. The tool's hardness, uniformity, and stability during use rely heavily on the quality of carbide distribution and the heat treatment process. Therefore, it's wise to allocate both time and resources for proper heat treatment. Cutting corners to save costs on this step can lead to risks and greater expenses in the long run. Heat treatment cost. The cost of heat treating depends on various factors, including the material type, weight of the item, and the specific process used. And also, heat treatment typically accounts for approximately 5% of the total cost in manufacturing or metal processing operations. This percentage reflects the expenses associated with energy consumption, specialized equipment, and operational labor required for the heat treatment process. Although this portion may seem relatively small, it plays a critical role in achieving the desired material properties such as hardness, durability, and resistance to wear. Proper cost allocation ensures efficiency and quality in the final product. Who require the heat treatment? Heat treatment is crucial in aerospace, defense, marine, and automotive industries to enhance material, strength, durability, and resistance to wear and fatigue. It ensures components can withstand extreme stress, harsh environments, and high-performance demands, meeting the strict safety and reliability standards required in these advanced fields. How is heat treatment performed? Heat treatment involves heating a metal or alloy to a specific temperature, maintaining it at that temperature for a set period, and then cooling it. This process alters the material's properties, enhancing strength, hardness, or ductility, depending on the treatment type, such as annealing, quenching, or hardening. Heat treatment, perform, such as vacuum. Heat treatment, protective atmosphere. Heat treatment, cryogenic treatment, plasma and gas nitriding. Heat treatment, process hardening, gas, oil, and salt, quenching, carburizing, nitrocarburizing, normalizing, stress, relieving or tempering, bright, annealing solutionizing, aging, plasma nitriding, gas nitriding, brazing, vacuum, flame torch, proactive atmosphere, cryogenic treatment, sub-zero. Hardening involves heating metal to a high temperature followed by rapid cooling, quenching, to increase hardness and strength. Normalizing, heating metal to a specific temperature and air cooling it to refine its grain structure and improve toughness. Tempering. Applied after hardening, this process reduces brittleness by reheating metal to a moderate temperature and cooling it. Annealing. Metal is heated to its recrystallization temperature and cooled slowly in a furnace to enhance ductility and relieve internal stresses. Solutionizing. Heating alloys to dissolve solute elements into a solid solution, followed by rapid cooling to retain the solution. Aging. After solutionizing, alloys are held at a moderate temperature to precipitate solute elements, enhancing strength. Plasma nitriding. Surface hardening method where nitrogen ions are infused into the metal surface using plasma. Brazing. Joining metals by melting a filler metal into the joint at a temperature below the base metal's melting points. Cryogenic treatment. Cooling materials to very low temperatures, e.g. liquid nitrogen, to increase hardness, wear resistance, and stability. Applications. Tools and dies used for processes such as stamping, forging, embossing, forming, cutting, and extrusion. Precision mechanical parts. Includes components like gears, pinions, shafts, jigs, fixtures, wheels, and cams. Electronic parts. Stamped parts made from materials like beryllium copper, stainless steel, and carbon steel. Casting. Applied in industrial and aerospace sectors, using materials ranging from carbon steels to high alloy steels. Here is some example for advantages of vacuum heat treatments and non-vacuum treatments. Heat treatment shop floor. The following topics will be covered on the channel: industrial safety, basic safety instructions, furnace, basic maintenance. What is heat treatment? Heat treatment processes, heat treatment, production, marketing, and quality management systems, basic metallurgy, heat, treating materials, classification scheme for various metal alloys, special characteristics of steel, uses of materials, aerospace plasma, nitriding, powder, metallurgy, special process brazing, and many more.